black holes, mysterious, violent, and yet beautiful. They are among the strangest and most powerful objects in the universe. But where do they come from? What happens if you fall into one? And how do they die? Today, we explore black holes from their birth to their final explosion. Alright, now that we've got your attention, let's answer some important questions. What is a black hole? Well, think of it this way. Black holes are like cosmic vacuum cleaners. They have an incredibly strong gravitational pull that sucks everything towards them. Nothing, not even light, can escape their grasp once it crosses a certain point, called the event horizon. What happens inside a black hole? Well, that's where things get a little weird. We don't really know what happens inside a black hole because it's impossible to observe. Anything that goes into a black hole disappears from our view forever. Some scientists believe that black holes lead to other dimensions or universes, but that's just speculation. Others believe that black holes are portals to the past or future. These theories are based on the fact that time is relative and can be affected by gravity. Since black holes have a very strong gravity, it's possible that time could slow down or even stop near them. But again, it's just a theory. Now that we know what a black hole is and what happens inside one, let's take a journey to the center of the Earth and find out how it's born. Believe it or not, black holes are actually born from stars. Stars are giant balls of gas that produce energy through nuclear fusion. As a star ages, it begins to fuse hydrogen into helium in its core. This fusion process releases a tremendous amount of energy that creates a strong outward pressure. The outward pressure balances the inward pull of gravity, keeping the star stable. However, as the star ages further, it begins to fuse heavier and heavier elements until it reaches iron. Iron is the end of the line because it doesn't release energy when fused. The star's core collapses in on itself, triggering a supernova explosion. If the core of the star is dense enough, the collapse continues until a black hole is formed. But why does the core collapse in on itself? Let's break it down. Star's core is made up of protons and neutrons packed tightly together. When iron is formed, the core reaches a state of maximum stability. Any further fusion would require more energy than the star could produce. Without the outward pressure from nuclear fusion, the inward pull of gravity causes the core to collapse. As the core collapses, the protons and neutrons are forced closer together. This increases the density of the core, creating an immense amount of pressure. The pressure is so great that it overcomes the electrostatic repulsion between the positively charged protons. The protons and neutrons begin to combine, forming heavier nuclei. This process releases energy in the form of gamma rays, which heats the core to millions of degrees Celsius. At this point, the core is a hot, dense ball of subatomic particles. The collapse continues until a black hole is formed. And speaking of collapsing, did you know that there are different types of black holes? Let's take a look. There are three main types of black holes: stellar mass, intermediate mass, and supermassive. Stellar mass black holes are the most common type, and they are formed when a star collapses in on itself. As we discussed earlier, these black holes typically have a mass of a few times the mass of our Sun. Intermediate mass black holes are much rarer, and they are thought to form when smaller black holes collide and merge. These black holes can have a mass of hundreds or thousands of times the mass of our Sun. Supermassive black holes are the largest type of black hole, and they can have a mass of millions or even billions of times the mass of our Sun. These black holes are found at the centers of most galaxies, including our own Milky Way. So, how big is a black hole exactly? Well, it all depends on its mass. The more massive the black hole, the larger its size. The size of a black hole is determined by the distance from its center to the event horizon. The event horizon is the boundary around the black hole beyond which nothing can escape. The larger the black hole, the larger the event horizon. That's a lot of space. Just imagine being trapped inside a black hole. You would never be able to escape. You wouldn't even be able to see anything. It would be completely dark. The only thing you would hear is the sound of things being pulled into the black hole. That would be pretty scary, right? But what happens when a black hole swallows something? Let's take a look at what happens to light when it enters a black hole. Light is an electromagnetic wave that travels at the speed of light. When light approaches a black hole, it is bent by the intense gravity. The light wave is stretched, becoming a sine wave with a longer wavelength. As the light approaches the event horizon, the wavelength becomes so long that it is no longer visible light. It becomes what we call gravitational redshift. Eventually, the light is pulled into the black hole and disappears from view. But what if instead of light, it was you falling into a black hole? Now, here's where things get really interesting. Let's assume you're falling into a black hole feet first. Your upper body would still be outside the black hole, where time would be relatively normal. Your lower body would enter the event horizon and time would slow down for your legs. The difference in time between your legs and your upper body would increase as you fell further. Eventually, your entire body would cross the event horizon and time would slow down to a halt. You would appear frozen from the perspective of an outside observer. From your perspective, time would continue to pass normally. However, you wouldn't be able to see anything because you would be in total darkness. You would also be unable to move forward due to the immense gravity, but you could still move sideways. You would be stuck in a two-dimensional world, unable to move forward or backward. You would also be unable to turn around and go back up, as that would require you to travel faster than the speed of light, which is impossible. But wait, there's more. As you approach the singularity, the gravity would become so intense that it would start to tear you apart. This process is called spaghettification. Your body would be stretched and torn apart along the direction of the gravitational pull. You wouldn't be able to scream or make any sound because the air would be compressed so much that sound waves could untravel. You would be utterly alone in the darkness, completely trapped and unable to do anything. But how does a black hole die? Believe it or not, black holes do eventually die. They die through a process called Hawking radiation. Stephen Hawking discovered in the 1970s that black holes aren't entirely black, okay? They emit a faint glow due to quantum effects, okay? This glow is called Hawking radiation, and it's a form of thermal radiation, okay? The temperature of a black hole is inversely proportional to its mass. The larger the black hole, the smaller the temperature, and the slower the evaporation. Conversely, the smaller the black hole, the larger the temperature, and the faster the evaporation. Black holes evaporate over incredibly long periods of time. For example, the smallest black hole known to exist is about 3.3 times the mass of our Sun. It would take about 200 million years to evaporate completely. On the other hand, the supermassive black hole at the center of the Milky Way is about 4 million times the mass of our Sun. It would take about 10 to the 90th power years to evaporate completely. That's a very, very long time. So there you have it. Black holes are truly fascinating objects that play a crucial role in shaping the universe. From their birth in the hearts of dying stars to their eventual death through Hawking radiation. They continue to amaze and intrigue scientists and space enthusiasts alike. We hope you enjoyed learning more about black holes and stay tuned for more exciting discoveries from the world of space exploration. Thanks for watching.